Dear learners and my dear student, first of all, I take an opportunity to welcome you at my M.Sc. Analytical Chemistry class. I am Dr. S.R. Labhade, working as Associate Professor in the Department of Chemistry at KTM College, Nasik. Student, in today's lecture, we solve some numericals based on stripping voltammetry. In previous lecture, we discussed the qualitative and quantitative applications of stripping voltammetry. In addition to this, we also discussed the sensitivity of stripping voltammetry over the classical technique of polarography. Therefore, problem number 1, an anodic stripping voltammetry at platinum disc electrode was used to assay water sample for copper 2+. The potential was initially adjusted to minus 0.5 volt versus saturated caramel electrode for 5 minutes prior to scanning. Analytically at a scan rate 50 millivolt per second. The height of stripping peak, stripping peak current was recorded and as shown in table. Determine amount of copper in water. Determine amount of copper in water sample. The result is like this. Here, concentration of copper 2+ in the order of 10⁻⁵ volts. Concentration of copper in the order of 10⁻⁵ and peak current IP here 4.0, here IP is 4.82, 8.0, 9.62, 67 for sample. It is equal to 5.36. From this information, we have to find out the amount of copper in the water sample. This problem, in this case, 2 measurements are carried out with the standard and 1 measurement is carried out for sample. And therefore, by comparing the proportionality constant obtained in a standard solution, we can find out the concentration of copper in the sample solution. Therefore, in anodic stripping voltammetry, at a fixed scan rate and deposition time, in anodic stripping voltammetry at a fixed scan rate and deposition time, peak current directly proportional to concentration of the analyte. Therefore, here we can write here IP is equal to K into C, concentration of analyte, and therefore K is equal to IP upon C. Therefore, K1 for first solution, that is IP is 4.82 divided by 4.0 into 10 raised to minus 5 moles. Here this is in microampere. Therefore, this value is 1.205 into 10 raised to 5 microampere per mole. Similarly, K2 is equal to 9.67 microampere divided by 8.0 into 10 raised to minus 5 moles. Here, this value is equal to 1.209 into 10 raised to 5 microampere per mole. If we take an average value of this K, therefore K proportionality constant average, that means this plus this divided by 2 equal to 1.207 into 10 raised to 5 microampere per mole. Now from this standard value or standard solution, we have an average value of K. Now we can use this K for sample. Therefore, for sample, peak current is known, that is 5.36. IP is equal to K into C. Therefore, C is equal to IP upon K. IP for sample, that is 5.36 divided by K, 1.207 into 10 raised to 5. This is in microampere. This is in microampere per mole. When we solve this, the answer for this equal to 4.44 into 10 raised to minus 5 mole. This is the amount of copper present in the water sample. Therefore, here this method is based on calibration curve method. In this case, the standard solution and sample solution are matched for determination of concentration of sample. Student, now we solve second problem based on anodic stripping voltammetry for determination of lead in the blood sample by a standard addition method. The problem is like this. A 0.2 ml of blood sample was digested with perchloric acid and HNO3 and analyzed by anodic stripping voltammetry using hanging mercury drop electrode. The pre-concentration state, concentration of Pb2 plus was carried out at minus 0.6 volt versus saturated galvanic electrode, and in stripping state the peak current was observed at observed at minus 0.401 volt was 2.37 microampere. In same sample, a 0.2 ml of Pb2 plus 0.2 ml of 2.16 into 10 raised to minus 8 moles of Pb2 plus solution was added and both steps were repeated. In second step, the peak current at minus 4.01 volt was observed equal to 4.88 microampere. Determine concentration of lead in blood sample. Now in this case, a blood sample was digested, that is heated with perchloric acid and nitric acid by using anodic stripping voltammetry and hanging mercury of electrode. The pre-concentration of analyte is carried out at minus 0.6 volt and stripping current was observed equal to 2.37. In same solution, 0.2 ml of 2.16 into 10 raised to minus 4 moles of lead solution was added. Both concentration as well as stripping steps are repeated. In second stripping step, the peak current at same potential was observed equal to 4.88 microampere. From this information, we have to find out the amount of lead in the blood sample. Student, this problem is based on standard addition method. Therefore, in standard addition method, concentration of sample is equal to, here IP for sample, IPX plus S minus IPX into concentration of standard into volume of standard upon volume of sample. This formula is used to find out the amount of analyte by a standard addition method using STP-7. Therefore, concentration of lead is equal to, or you can write in this way, lead is equal to IPX for sample is 2.37. For IPX of sample and standard is 4.88 minus 2.37 into volume of, concentration of sample is 2.16 into 10 raised to minus 8 mole upon into volume of standard is 0.2 ml upon volume of blood sample is 0.2 ml. Here volume are set. Therefore, concentration of lead when we solve this equal to 2.37 divided by 2.51 into 2.16 into 10 raised to minus 8 moles. When we find out, the final answer is equal to 0.944 into 2.16 into 10 raised to minus 8, which is equal to 2.039 into 10 raised to minus 8 mole is the concentration of lead. Therefore, this method is based on standard addition method, and by standard addition method we can find out the concentration of a sample that is lead in the blood. Here two measurements are carried out, one for standard containing sample, second for sample. Then results are matched using this formula. We can find out the concentration of lead in the blood sample. Student, now we solve the next problem based on anodic stripping voltammetry, that is determination of cadmium in seawater sample. A 1.0 ml of seawater sample was assayed for the cadmium content using anodic stripping voltammetry. The result of analysis are shown in table. Determine the amount of cadmium in determine the level of cadmium in seawater. The result of the analysis is presented in the table, and that result is like this. Here sample plus 10 ppm cadmium gives peak current 2.24 microampere. Here same sample plus 30 ppm cadmium gives a peak current 4.71 microampere. With this information, we have to find out the amount of cadmium in the seawater. Student, this is also a problem based on a standard addition method. Here a current is measured as a function of ml of standard added. Here at addition of 10, 20, 30 and 40, here we have a peak current, and when we connect these two points, then this is the concentration of a sample. But here this peak current in the table is 2.24 microampere, and this peak current is equal to a 4.71 microampere. With this information, we have to find out the amount of cadmium in the seawater. Now here this problem is also based on the standard addition method, but we can find out the concentration of cadmium by using this formula. That is a by means of slope method. This method is called as a slope method. In this case, concentration of cadmium is equal to IP1 into C2 minus IP2 into C1 divided by C2 minus C1. Sometimes the mod of this formula is taken. Concentration of cadmium is equal to IP1 is 2.24 into C230 minus IP2 is 4.71 into C1 is 10 divided by 30 minus 10. Therefore, concentration of cadmium is equal to this into this equal to 67.2 minus 47.1 divided by 20. Therefore, here equal to 20.1 divided by 20, which is equal to 1.001, that is a milligram per liter, or it is a ppm. This is the level of cadmium present in the seawater. In this way, the concentration of cadmium that can be determined by means of a slope method, which is also a technique of standard addition method. Student, this is all about the different numericals of the stripping voltammetry. Now the home assignment. Give the principle of stripping voltammetry. Second question is that what are the steps involved in stripping voltammetry? Explain the working of anodic stripping voltammetry and cathodic stripping voltammetry. Compare anodic stripping voltammetry and cathodic stripping voltammetry with respect to the steps of analysis, and next question, give the qualitative and quantitative applications of stripping voltammetry. And last question, compare sensitivity of anodic stripping voltammetry over polarography. You also solve the numericals based on standard addition method, calibration curve method of stripping voltammetry. Student, this is all about the different applications and numericals based on the applications of stripping voltammetry. With this, we stop here. Thanks for joining me. Keep learning. Happy learning.